This video will review the classifications of angles as well as a lot of the terminology and apostolate that goes along with angles. At the top of your screen, you'll see an angle that has the interior points labeled and the exterior points labeled. So any point that's between the two sides of the angle would be on the interior, and any point not between the two sides of the angle would be on the exterior. Now, in addition to the segment addition postulate that we went over a couple of days ago, there's also the angle addition postulate, but the idea is the same. If you have two adjacent angles, you can take the blue angle, take its measurement, and the red angle, take its measurement, and add them together to get the entire measurement of what's labeled here as the green angle. So the angle addition postulate works as long as the angles are adjacent to each other. And over in the instructions, it talks about P being on the interior of angle RST, and that would be necessary in order for them to be adjacent. So let's do an example using the angle addition postulate. Let's use this given information and write it right on the angle so we can see if we can come up with an algebraic equation to help us solve for x. So AJX is 4x plus 20. So let's put that in the angle AJS. AJI, so the whole thing, this entire angle here, this entire angle is 57 degrees. And the last piece, SJI, is 7x plus 4. So with the angle addition postulate, these two smaller angles should add up to the larger one. So 11x plus 24 should equal 57. So 11x, if we subtract 24 from both sides, is 33. So x is 3. And let's click down here and see if we got the same answer, and we are correct. There are 4 classifications of angles that we're going to work with in geometry. An acute angle is one that's between 0 and 90. Notice that it doesn't say including 0 and 90. So a 90-degree angle is a right angle, and it'll oftentimes be denoted with the square in the box or square in at the vertex. An obtuse angle is one that's greater than 90 but less than 180. If it's 180, then it's a straight angle and it looks just like a line. Adjacent angles are angles that have 2 conditions. The first condition is that they have to have a common vertex, so you can see they have a vertex here of M, and a common side, so the side in this case is ME, the ray ME, and no common interior points. If you go back and look at that first screen again, you'll remember that interior points are the points that are between the two sides. So adjacent angles can't have any of those in common. So we're given 2 choices over here at the right. Which 2 are adjacent? And let's use some colors to help us here. GME is this angle here, and I'm going to shade in green the interior points. GMO is this angle here, and we'll shade in the interior points. Now, they in fact do have a common vertex. The common vertex is M. They share a side. The side that they share is MG. Do they have common interior points? Yes, they do. You can see in this area here, their common interior points are overlapping, and that's not okay for adjacent angles. So the first choice that they gave us could not be adjacent angles. We're going to put an X through these. Let's try this other set. GME. So we'll shade that in red. There's the interior points. EMO. We'll shade that in blue. The interior points are shaded. Do they fit the criteria for being adjacent? Do they have a common vertex? Yes, they have a vertex of M. Do they have a common side? Yes, their common side is ray ME. Do they share any interior points? No, and they shouldn't share. because it says there's no common interior points.